Hello there and welcome to the video that's going to go through a whole bunch of questions on proving trigonometric identities with sine, cos, tan and the new three, sec, cosec and cot, to hopefully develop your ability to prove trigonometric identities step by step. So we'll start with easy ones, we'll work our way up to harder ones, and in each question, try the question before watching the video. You'll gain more from it doing it that way. So let's get started on a hopefully nice easy one. Cos theta plus sine theta tan theta is identical to sec theta. Now with these types of questions, you can't move things from one side to the other. You have to start on one side and continually work on that side, manipulating it algebraically until it's equal to the right hand side. Well, I would choose the more complicated side and go to the easier side. In this case, the left hand side looks way more complicated, so that's why I write LHS, left hand side. This side is way more complicated. And you'll also notice there is a triple equals to sign in the middle there, not just a double one. Now we use triple equal to signs when it doesn't matter what value of theta we use, as long as it's consistent, say for example 20, 20, 20 and 20, the left hand side should be equivalent to the right hand side. You'd use a equal to symbol when there's only maybe one, two, or maybe just a select few amount of solutions to the equation. This is an identity where it always works. The left hand side is always equal to the right hand side. But anyway, I digress. Let's get started on proving this trig identity. We'll start with then cos theta plus sine theta tan theta. And we've got to think of what trig identity we could use to help us in this situation. Now we've got nothing like sine squared plus cos squared equals 1 because there's no squareds around, but we have got tan theta. Now tan theta, if you remember, can always be written as sine over cos. So that's what we'll do then. We'll write tan as sine over cos. Right, so next step will be to expand those brackets. Now when you're timesing a fraction by a value, so for example sine over cos times sine, the sine only multiplies onto the top. So it now becomes sine squared theta over cos theta. Now probably what we want to do here is we probably want to add these fractions together, so we'll need the left hand expression to be over cos as well. So that means it's going to need to be cos squared on the top, because I'm effectively timesing top and bottom here, by cos. Okay, so now what I've got is sine squared theta over cos theta. So now we've got common denominator, let's add the two together. So we'll have a common denominator of cos, and then it's going to be cos squared theta plus sine squared theta on the top. And hopefully this is ringing alarm bells that you know that sine squared plus cos squared on the top, that will simplify to just 1. You know that identity off by heart. Equals 1 over cos, which is equal to sec theta. So there we are, that's the answer for this first question then. So we've gone through it stage by stage using trigonometric identities, adding fractions where possible, until we get all the way to sec theta, which is equal to the right hand side. And you've got a clear structure of going from left hand side, something equivalent, 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 equals the right hand side. So left hand side through a chain of equals to symbols is equal to the right hand side. And once you've proved something, put a little box down the bottom, because that's what you do when you prove something. Let's move on to the next one then. Cot theta plus tan theta is identical to cosec theta, sec theta. What we'll probably do is we'll probably work on the more difficult side. I reckon that's the left hand side in this case. But let's think about what the right hand side is so we know where we're heading towards. Cosec theta is 1 over sine theta, and sec theta is 1 over cos theta. So on the left hand side it's effectively 1 over sine times 1 over cos. That's where we're heading towards. Let's get started on cot theta then. So left hand side equals cot theta plus tan theta. And what do I know about cot theta and tan theta? Well, I know that cot theta is 1 over tan, but that's really not going to help me get towards sine or cos. The other identity I know for cot is that it's equal to cos over sine. Plus, and the tan one is sine over cos. Okay, so we're setting this equal to something that is a combined function, a combined expression rather, no addition in the middle, so we'll need to add these two fractions together with common denominators. So on the first one, we need an extra cos on the bottom, sine theta, cos theta. So on the top, we need an extra cos theta as well, so that's going to become cos squared theta. On the right-hand expression, we need an extra sine theta on the bottom. So we need an extra sine theta on the top to make it equivalent. So it's going to be sine squared theta. Now that we have a common denominator of sine theta, cos theta, we can add the fractions together. So it's going to add together to make cos squared plus sine squared. And from the previous video and from your general knowledge, you should automatically know that sine squared plus cos squared equals 1. So the numerator just becomes 1. And you can see where this is going now. It's forming the right kind of shape. It's heading towards 1 over sine times 1 over cos. So this is equal to 1 over sine times 1 over cos, which is equal to cosec theta sec theta, which is equal to the right hand side. Lovely, there we are. So that's gone from left hand side, the more difficult side. You could have picked the right hand side, but it's easier to go from the left hand side in this case. Harder to easy is a bit easier. Right then, let's get started on this one. We've got cosec theta minus sine theta is identical to cos theta cot theta. So let's start with the left hand side. Left hand side gives us 1 over sine theta minus sine theta. So what can we do here? Well, I suppose we could subtract the two fractions by creating common denominators. That's going to be 1 over sine minus sine squared over sine. Now subtract the numerators because we've got a common denominator. 1 minus sine squared, hopefully that's ringing a bell that is equal to cos squared because sine squared plus cos squared equals 1. And let's just have a look at splitting this up now. We'll split it into cos theta times cos theta over sine theta. And look at that, we've now got cos theta times cot theta, which is exactly what we're looking for on the right hand side. Lovely, let's move on to the next one. Right then, let's have a look at this one now. So it's sine theta cos theta bracket sec theta plus cosec theta is identical to sine theta plus cos theta. So which one is the more difficult side? I think the left hand side in this case is more difficult. So this is equal to sine theta cos theta bracket sec theta plus cosec theta. Okay, so let's now expand the brackets. In fact, what we'll do first is we'll consider writing sec theta and cosec theta as their 1/overs, as their reciprocals. So it's going to be 1 over cos plus 1 over sine. Okay, let's now expand the bracket. So we're going to be timesing sine theta cos theta by 1 over cos theta. Now what will happen there is the cos thetas will cancel out and you'll just be left with sine theta. And then expanding the brackets again, when you times sine theta cos theta by 1 over sine theta, the sine thetas will cancel out and you'll be left with sine theta plus cos theta. Oh, that was a really quick one, wasn't it? So that's equal to the right hand side. Lovely, let's move on to the next one. Okay, so we've got here 1 minus cos theta bracket 1 plus sec theta, and this is equal to sine theta tan theta. Let's just have a think about what the right hand side is, because I'm going to start on the left. It's going to be sine theta times sine over cos. So I'm expecting to get sine squared over cos. Let's have a go at it and let's see what we get. So start with the left hand side. And we're going to start by expanding the brackets. So we're going to get 1 plus sec theta. And then it's going to be minus cos theta. And then it's going to be now minus cos times sec. They're reciprocals of each other, so they'll cancel each other out. So we'll be left with minus 1. So the 1 and the minus 1 will cancel each other out. So we're now left with sec theta minus cos theta. Sec theta is 1 over cos theta. So let's now combine these fractions together by making sure we have a common denominator. So it's going to be 1 over cos minus cos squared over cos. Let's now put the two together now that we have a common denominator of cos on the bottom. So it's going to be 1 minus cos squared. And hopefully this is ringing alarm bells that 1 minus cos squared is equal to sine squared. By cos squared plus sine squared equals 1. So now this is equal to sine theta, and we know where we're going from here because we've got it on the top right. We kind of did a little bit of advanced work on the other side beforehand. Sine theta times sine theta over cos theta is equal to sine theta times tan theta, which is exactly what we have on the right hand side. Lovely jubbly. Okay, let's move on to the next one. Right, then let's get started on this one. We've got 1 minus sine theta times 1 plus cosec theta is equal to cos theta cot theta. Let's get started on the more difficult side, the left-hand side, and let's start by expanding the brackets. We've got 1 plus cosec theta minus sine theta, and then minus sine theta times cosec. Well, cosec is just 1 over sine, so that will give us minus 1. So the ones will cancel out at the front and the back, and we've now just got 1 over sine theta minus sine theta. Let's create common denominators. 1 over sine theta minus sine squared over sine theta. Let's subtract one from the other. 1 minus sine squared theta over sine theta. 1 minus sine squared is cosec squared over sine theta. And let's now just break this up a little bit. Cos theta times cos theta over sine theta is equal to, and look at what we have cos theta cot theta. Lovely, and that's equal to the right hand side. Great, let's now move on to the next one. Okay, so let's get working on this one. We've got tan theta plus cot theta times by sine theta sine theta plus cos theta is identical to sec theta plus cosec theta. Let's start by changing the tan and cot into sine and cos. So let's write this as sine over cos plus cos over sine. And then we're going to multiply this by sine theta plus cos theta. So expanding the brackets, we're going to get sine theta over cos theta times sine theta. That would be sine squared theta over cos theta. Next one, sine theta over cos theta times cos theta. That would just be sine theta. Next one would be cos theta over sine theta times sine theta. That would just be cos theta. And the next one is going to be cos theta over sine theta times cos theta. That would be cos squared theta over sine theta. Okay, so now we've got to combine all of this. Let's think about what we're heading towards. We're heading towards 1 over cos theta plus 1 over sine theta. So really all of these denominators need to be cancelled out at some point. And we're probably thinking, well, something to do with sine squared plus cos squared. Let's have a look at what we've got. Let's perhaps create common denominators. So let's create a common denominator for everything of cos sine. So the first term is going to turn into sine cubed theta. The second term is going to turn into sine squared theta cos theta. The third term is going to turn into cos squared theta sine theta. And the last term is going to turn into cos cubed theta. Okay, so what we're trying to do now is we're trying to spot sine squared plus cos squared equals 1 from all of these components. Let's just take the first, this one here and this one here, first of all, and factor out cos from it. So it'd be cos theta, and then what's left over is going to be sine squared theta plus cos squared theta. Lovely, so that's the first one, and then we'll do the same with the other two, factorising out sine. So it's going to be sine theta bracket sine squared theta plus cos squared theta. Great, so that's going to be over cos theta sine theta. So all these sine squared plus cos squares will just cancel out to 1, so we're then left with cos theta plus sine theta. And we'll split the fractions up in the same step as well. So this will be over cos theta sine theta, and this one will also be over cos theta sine theta. So for the left hand one, we'll cancel out cos from top and bottom to give us 1 over sine. And for the right hand expression, we'll cancel out the sine from top and bottom to leave us with 1 over cos. Remember that when you cancel out something from a fraction and you've got nothing left on the top, you effectively equivalently have a 1 on the top, not a 0. Which is then equal to sec theta plus cosec theta. Lovely, there we are, and that's equal to the right hand side, little box. Great, so that's the answer to this one. Let's move on to the next one. Okay, next one then. So sec squared theta plus cosec squared theta is identical to sec squared times cosec squared theta. So let's start with 1 over cos squared. So this is left hand side equals and 1 over sine squared theta. Let's create common denominators on both of them. So they're both going to have a common denominator of cos squared theta sine squared theta, and on the first one we need to turn this into sine squared on the numerator, and on the second one we need to turn it into cos squared on the numerator. Sine squared plus cos squared equals 1, so that numerator will just turn into 1. And then we have 1 over cos squared times 1 over sine squared, which is equal to sec squared theta cosec squared theta, which is equal to the right hand side. There we are. So that's the answer to this one. Let's now move on to the next one. Okay, so we have 1 minus cos squared theta. We know that 1 minus cos squared theta is basically the same as sine squared theta, so that's what we're heading towards. Let's actually, for a change, work on the right hand side first. So let's start by expanding the brackets. We're going to get sec squared x, then it's going to be sec squared times minus sine squared. So that's going to be, well, I'll write it out in terms of sines and coses. Sine squared over cos squared, same as tan squared here. Then it's going to be minus 1, and then what's the last one? Minus sine squared. Okay, so let's rewrite all of this as, oh hold on, we've got sec squared here, minus tan squared here. Now this identity rings a bell. Not quite sure, but let's take sine squared plus cos squared equals 1, divide by cos squared across the identity, and therefore we get tan squared theta plus 1 equals sec squared theta. So if I now take tan squared onto the other side, I get sec squared theta minus tan squared theta. So sec squared minus tan squared, this component here would purely simplify down to 1. So this is turning into 1 minus tan squared. So 1 minus 1 cancel out, and we've now just got oh sorry, it was meant to be plus sine squared all along, because in minus terms of minuses are positive. So that's positive sine squared, which is equal to 1 minus cos squared, which is equal to the left hand side. Lovely, so a little bit of a cheeky one there, starting from the right hand side, moving to the left hand side, and yeah, don't forget your double negatives like I did, silly me. Right, so that's the answer to this one. Let's move on to the next one. Right, sec squared times cot squared theta minus cos squared theta is identical to cot squared theta. Let's start with the left hand side. So that's going to give us, let's write it all as sines and coses. So it'll be 1 over cos squared, and expanding the brackets, this will be multiplied by cos squared over sine squared. minus, and then multiplying out this bracket. Well, cos squared is just 1 over cos, sec squared is 1 over cos squared, so actually when you expand that to that, you just get 1. Okay, so let's carry on now. So we're going to get here cos squared's cancelling out top and bottom, so this is going to give us cosec squared minus 1. And hold on, this identity rings as bell as well. If we take sine squared plus cos squared equals 1, and divide by cos, no, we don't divide by cos squared here, we divide by sine squared here. That was for the, cos squared was for the last one. We get 1 plus cot squared theta equals cosec squared theta. You could also remember this as an identity, but if we then take away the 1 onto the other side, we get cosec squared theta minus 1, which is exactly what we have on the left hand side here. So this is identical to cot squared theta by the identity that you can either memorize or quickly derive, as I did on the right hand side of the page there. So there we are, that's the answer to this question. Let's now move on to the next one. Right, so the next one is cosec squared minus sine squared equals cot squared theta plus cos squared theta. In this case, I don't think it really matters where we start. What I might even do here is I might do a little bit of work on both sides and see if we can kind of meet halfway in the middle. It's not recommended, and you kind of have to make sure you've written everything clearly, but we'll see if we can meet in the middle. So in this one here, it's going to be 1 over sine squared theta minus sine squared theta. Let's now expand the right hand side as well. So this is going to be cos squared theta over sine squared theta plus cos squared theta. So with this right hand side we can create common denominators. It's going to be cos squared theta plus cos squared theta sine squared theta all over sine squared theta. Cancelling, so factorising out the cos squared, is that going to be worth my while? I don't know, I'll work on the left hand side now I think, so this would turn into 1 over, it'll be all over sine squared theta minus sine to the 4 theta. I could do difference of two squares on this, 1 minus sine squared theta, 1 plus sine squared theta over sine squared theta. Now 1 minus sine squared theta is cos squared. Oh, this is turning very similarly into what I have on the right hand side. 1 plus sine squared theta over sine squared theta. So let's turn the right hand side into exactly what we've got here. Cos squared theta, open bracket, 1 plus sine squared theta over sine squared theta. And there we are, you can see what we have now is the same thing on the left hand side as the right hand side. So therefore, left hand side equals right hand side, and we've now proved the proof. So proved the identity using a bit of work on the left hand side, a bit of work on the right hand side, and we've shown the two things are equal to. It's not a recommended method because generally it's better to work from one hand side to another, but in rare occasions like this where it's a bit difficult to spot where to start or both sides are extremely difficult, you can, if you've laid out your work clearly, you can work like this, but it's not recommended. Right, so that's the answer to this question. Let's move on to the next one. Okay, next one then. So what I might do is I might use this left hand side, right hand side method. So left hand side is equal to 1 over cos squared theta minus cos squared theta. And on the right hand side, we have, expanding the brackets already, sine squared theta plus, now when I expand that, that will give me tan squared theta. Okay, so what I'll do here then, in fact I don't think I need to use the left hand side, right hand side method. In fact what I'll do is I'll just recall two identities. So I'll recall that sine squared plus cos squared equals 1. And I'll also recall that tan squared theta plus 1 equals sec squared theta. So what I'll do then on the left hand side is I'll turn sec squared theta into tan squared plus 1, and on the right part of it, the minus cos squared part, if I take the minus cos squared, take the cos squared onto the other side, if I take the sine squared onto the other side, it'd be 1 minus sine squared theta. So then let's expand the brackets. We're going to get tan squared theta plus 1 minus 1 plus, for the double negative there, sine squared theta. The ones and the minus ones will cancel each other out. So we've now just got tan squared theta plus sine squared theta. Let's now factor out sine squared theta. Sine squared bracket cot, so sec squared theta plus 1, which is exactly what we have on the right hand side. So it took a little while getting warmed up with that one, so I didn't need that part eventually, and there we are. So we've just used a tan replacement for sec squared and a sine replacement for cos squared, and then we ended up ones cancelling out and then factorising to get what we needed here. Great, so that's the answer to this one. Let's now move on to the next one. Right then, sec to the power of 4 theta minus tan to the power of 4 theta equals sec squared theta plus tan squared theta. Oh, this is actually quite easy. If you can spot the difference of two squares here, this question is not difficult at all. Just factorise it. Sec squared theta plus tan squared theta, sec squared theta minus tan squared theta. Now once you've done that, so you can see that the left hand side is what you have on the right hand side, but let's just show that that is effectively equal to 1. We need to recall the identity that tan squared plus 1 equals sec squared theta. Let's now take the tan squared onto the other side. It will be sec squared theta minus tan squared theta equals 1. So therefore, the left hand side does now equal sec squared theta plus tan squared theta. Let's just write it all out, times 1. So therefore this is equal to sec squared theta plus tan squared theta, which is equal to the right hand side. Well, excellent. So there we are. We've proved this one here. Let's move on to the next one. Right, way more difficult this one, but still achievable. Cos theta over 1 minus sine theta plus 1 minus sine theta over cos theta equals 2 sec theta. Now what is 2 sec theta? That would be 2 over cos theta. So that's where we're heading. Let's see if we can get there. So left hand side, maybe leave yourself a lot of space for this one, is going to equal cos theta over 1 minus sine theta plus 1 minus sine theta over cos theta. Right, okay, so what can we do from here? Well, we can create common factors on the top and bottom and see what cancels out. So we're going to get cos theta squared over 1 minus sine theta times cos theta plus 1 minus sine squared, 1 minus sine theta squared over 1 minus sine theta cos theta. Okay, so there we are. We've had to times top and bottoms by kind of each other. So let's now try and put these together. So the denominator on both of them will be the same. It's going to be 1 minus sine theta cos theta. And on the top it's going to be cos squared theta plus 1 minus 2 sine theta plus sine squared theta. Okay, now what can we do with this? Okay, well we know that cos squared, if we link this one together and this one together, sine squared plus cos squared equals 1, so we get another one in addition to this one, so that's going to make it 2 minus 2 sine theta. I can see where it's going from here now, it's all taking shape, hopefully you can see it as well. 1 minus sine theta cos theta. Let's now move up here. Let's now factorise out the top. So 2, 1 minus sine theta over 1 minus sine theta cos theta. Now we can cancel out 1 minus sine theta from top and bottom, and we're left with 2 over cos theta, which is exactly what we have. Well, let's do one more step, which is equal to 2 sec theta, which is exactly what we have on the right hand side. Lovely, there we are. That was a really difficult one, that one. Hopefully you just kind of persevered with the fractions, adding the fractions together, creating common denominators. Spot that sine squared plus cos squared equals 1. The sine squared and the cos squared don't need to be together. As long as they're both positive and being added, then you can combine them together to make a 1. 1 plus the one other one, that gives you a 2. Factorising out the 2 gives you 1 minus sine theta. Cancel that out, and you're there. Right, let's move on to the next one. Right, now this one here is much more difficult, isn't it? We've got cos theta over 1 plus cot theta is identical to sine theta over 1 plus tan theta. Now, maybe what you're tempted to do is cross multiply here, but you're not allowed to move something from one side to the other. So the best we can do here is just work on one side, and hopefully it leads us to the other side. What I'm going to do here is I'm going to work on the side with cot, because I see that as a more difficult side to work with, because cot is a little bit, just a tiny bit more difficult than tan. But what can I do here? How can I turn it into this fraction here? Well, what I could do, I suppose, to start with, is I could have a look at what cot is. Cot is equal to cos over sine theta. Okay, now it's not great that I've got a triple tier on my fraction here. I've got a sign that's on the bottom of the bottom part of the fraction. So what I think I'll do to get rid of that sign that's on the bottom here is I'll times top and bottom by sine theta. Now let's see what effect that has. On the top, it's going to lead to cos theta sine theta over, now it's going to be sine theta plus 1, so sine theta times 1, so that would be sine theta. And then for the second part here, it's going to be cos theta over sine theta times sine theta, which will just leave us at cos theta. Okay. So this is what we've got so far, and we're heading towards this expression here, so let's compare what we've got and where we're going. Really, we only want sine on the top, so we're going to have to somehow cancel out the cos that's on the top. And we want a 1 plus tan theta on the bottom. Tan theta, remember, is the same as sine theta divided by cos theta. So now, what I'm going to do is I'm now going to divide by cos theta over cos theta. Remember, if you divide by cos theta over cos theta, that's just effectively dividing by 1, but I'm going to divide the top by cos theta and divide the bottom by cos theta. Let's see what we get. So cos theta sine theta divided by cos theta is just sine theta. And then on the bottom, we're going to get sine theta divided by cos theta, which is tan theta. And then we're going to get cos theta divided by cos theta, which is 1. And that's exactly what we have on the right hand side. Lovely jubbly. So there we are, that's the answer to this question here. A really difficult one, that one, so just bear in mind in the future that you can times top and bottom of a fraction by the same amount. It will change things around a little bit, but that's for the better. And you can divide the top and bottom of a fraction by the same amount as well, maybe to cancel things out, maybe to create tans in the future. However you want to do it, you can times top and bottom by the same value, and divide the top and bottom by the same value. Okay, so let's move on to the next one. Right, really difficult this one. So it's going to be cosec theta times, so it's cosec theta minus cot theta over 1 minus cos theta is identical to cosec theta. Right, so think about what the right hand side is. We're heading towards 1 over sine theta, so that's where we're going. So let's start with the left hand side, and we'll write cosec and cot as their 1 overs. So it's going to be 1 over sine theta minus, now cot, it might be better to write this as cos theta over sine theta. Now That's all going to be over 1 minus cos theta. Right, so it's not great that we've got this triple tier of fractions. On the top, it would be really helpful if we were to get rid of the sign that's on the bottom of these two fractions. So what we need to do is we need to times top by sine theta, but if we do something to the top, we must do it to the bottom of a fraction as well, so we'll times bottom by sine theta as well. So let's now multiply this out on the top. 1 over sine theta times sine theta is 1. Cos theta over sine theta times sine theta is cos. And then we'll leave the bottom factorised because you'll see why in a second. 1 minus cos theta multiplied by sine theta. Now what can you spot here? Well, we've got a common factor of 1 minus cos theta on top and bottom. That leaves us with 1 over sine theta, which is equal to cosec theta. And there we are, that's equal to the right hand side, and we've done this question. Let's move on to the next one. So this one is sine theta tan theta over 1 minus cos theta, take away 1 is equal to sec theta. Let's think about what sec theta is first. Sec theta is 1 over cos theta, so that's where I'm heading. Let's start on the left hand side though, the more difficult side, and turn the tan into sine over cos. So it's going to be sine theta times sine theta over cos theta over 1 minus cos theta. Take away 1 at the end. Right, okay, so I suppose what would be a sensible thing to do to start with is with this fraction, we'll times the top and bottom of it by cos. So we'll times top and bottom by cos. And the 1 on the outside doesn't get affected, just leave it on the outside there as minus 1. So let's times top and bottom by cos. On the top, it's going to be sine times sine divided by cos times cos. So the coses will cancel out on the top there, so we'll just be left with sine squared. And on the bottom, we're going to get 1 minus cos theta times cos theta. We'll leave it factorised, and then we've got to take away this 1. So what we'll do is we'll bring this 1 into play now. So to combine it with what we've already got, we need it to have the same denominator. So it's going to be 1 minus cos theta on the bottom here. So that's exactly what we're going to get over here. We're going to do 1 minus cos theta times cos theta over 1 minus cos theta cos theta. Might need a bit more space here. Right, so now that we can combine these two together, we can now subtract because we have common denominators. So we're going to get 1 minus cos theta, and then it's going to be sine squared. Let's now expand the brackets. Sine squared minus 1 times cos, so that'll be minus cos. And then it's going to be minus cos times cos, that'll be plus for the double negative there, cos squared. Now hopefully what you're seeing here is you're seeing sine squared plus cos squared on the top. Doesn't matter that they're not together because you can always rearrange addition and subtraction if you do it properly. Sine squared plus cos squared will equal 1. So on the top it's now going to turn into 1 minus cos theta over 1 minus cos theta times cos theta. And you can see what's going to happen here now and where we need to go with this. Cancel out the 1 over 1 minus cos theta on top and bottom, and we're left with 1 over cos theta, which is equal to sec theta, which is also equal to what we have on the right hand side. Lovely. So we've proven that question. Right, that's the end of that question. Let's move on to the next one. Wow, right, this is really difficult then. So we've got cot theta cosec theta over sec squared theta plus cosec squared theta. Okay, so let's see what we've got here. So left hand side. What I'm going to do with this left hand side is I'm going to write it all in terms of sines and coses. So starting with cot theta. Cot theta is equal to cos theta over sine theta. Then I'm going to multiply this by 1 over cos theta. So 1 over cos theta, that's 1 over sine theta, isn't it? Over 1 over cos squared plus 1 over sine squared. Right, we've got a 4-tiered fraction here, which is really not very helpful at all. So what we want to get rid of is as many of these bottom parts of the top fraction and the bottom fraction as possible. We'll try and do it all in one go if we can. So on the top I've got 2 multiples of sine, so I at least need to multiply by sine squared on the top and bottom. And that will help my denominator as well, because I've got sine squared on the bottom of this function, this expression here. But on the bottom of this one I've also got cos squared. So I'm also going to multiply top and bottom by cos squared. And from our answer, cos cubed, it looks like that might be potentially helpful, creating more coses. So this is a really difficult question where we're going to times top and bottom by cos squared sine squared. So let's get started in multiplying this out. Multiplying the top, cos theta over sine squared theta, by sine squared theta cos squared theta. The sine squared thetas will cancel out and we'll just be left with cos cubed theta. We've got 1 cos on the top here, 2 cos on the top here, so that makes 3 coses on the top, and the sines will cancel out on the top and the bottom. Let's do it for the next one as well. So we're going to do sine squared theta cos squared theta times just this one first, cos squared. Well, the cos squareds will cancel out and we'll just be left with sine squared. And on the second expression here, 1 over sine squared theta times sine squared theta cos squared theta. The sine squared will cancel out and we'll just be left with cos squared. And hopefully you've seen it now. Sine squared plus cos squared equals 1. So on the denominator it's just going to be sine cubed, which is equal to the right hand side. Great, so that's the answer to this question here. Little box for the answer. Right, so that's that question. Let's move on to the next one. Wow, right, okay, this question looks incredibly difficult then. I think what I'll do is I'll start with, I'm looking at both sides, not knowing where to start here. I'll start with the left hand side. Because what I immediately spot is a difference of 2 squares. So what I've spotted is that I can factorise this into cos squared theta minus cot squared theta, and then on the other side cosec squared theta plus cot squared theta. Okay, so lovely. Now I know that one of these simplifies down to 1. What's the identity that I can remember? Well, it's going to be, I can't really remember it, it's something to do with sine squared theta plus cos squared theta equals 1. But then if I divide everything by sine squared, so this is how I actually remember these identities. I don't remember them as facts, I remember them as derivations. So it's going to be 1 plus cot squared theta equals cosec squared theta. So therefore if I take cosec squared on, so if I take cot onto the other side, it's this one here that cancels out to be 1, because it'll be cosec squared minus cot squared equals 1. So now all I'm left with on the left hand side is cosec squared theta plus cot squared theta. Right, so I suppose that's made it a little bit more simple, but still, how are we going to get to this? Well, I'm just thinking about what I've got on the right hand side first. I can spot that the 1 minus cos squared theta could be simplified using sine squared plus cos squared equals 1 to sine squared. So actually what I'm going to look for here is not this, but 1 plus cos squared theta over sine squared theta. That's going to be a bit more easy to follow. What I'll do then, first of all, is I'll convert these into their 1/overs. So it's 1 over sine squared plus cos squared over sine squared. Okay, well they both have a common denominator, so it's now going to turn into 1 plus cos squared over sine squared. Hey, this is exactly what I was just talking about up the top. So coming back up to the top right, I can now rearrange sine squared into 1 minus cos squared, because that's just something that I've remembered from sine squared plus cos squared equals 1. So it's 1 minus cos squared theta, which is equal to the right hand side. Perfect. Great, so that's the end of that question. Let's move on to the next one. Right then, let's get started on this one. We have 1 minus tan squared theta over 1 plus tan squared theta is equal to 1 minus 2 sine squared theta. Well, there's an identity to do with 1 and tan squared. Let's just figure out what it is. We have sine squared plus cos squared equals 1. Divide that all by cos squared, and we get the identity that tan squared x plus 1 equals sec squared x. Okay. So we can replace, therefore, tan squared plus 1 with sec squared. So I don't know how helpful that will be, but let's get started on doing it. So we have 1 minus, it's tan squared theta over sec squared theta. Now what I've noticed is that tan squared will have a cos squared on the bottom of it. Let's write it out. 1 over sine squared theta over cos squared theta over 1 over cos squared theta. So you can see on the denominators here, both of them have cos squareds on the bottom. So what I'm going to do to cancel that out is I'm going to times top and bottom by cos squared. So what will happen here? Well, I'll have to multiply out the brackets on the top. 1 plus cos squared is cos squared, and sine squared over cos squared times cos squared is just sine squared. And on the denominator, 1 over cos squared times cos squared, that's just 1. Okay, so what we're left with now is cos squared minus sine squared. And now probably what we'll do is we'll replace the cos squared with 1 minus sine squared. And there you are, you can see it forming the shape that it needs to now. So it's now 1 minus 2 sine squared theta, which is equal to the right hand side. Lovely, there we are. So that's the answer to this question. Let's now move on to the next one. Okay, so this question is cot theta over cosec theta minus 1 minus cos theta over 1 plus sine theta is equal to 2 tan theta. Okay, so what I'm going to do is write out the left hand side in terms of sines and coses. So it's going to be cos theta over sine theta over 1 over sine theta minus 1. So minus 1. So what I'm going to do to this one here, very similar to the last one, is I'm going to times top and bottom by sine theta, because I can see there are denominators of sine theta on the top and the bottom, which will cancel them out. And then on the right hand fraction, it will be 1 cos theta over 1 plus sine theta. Okay, so what will happen on the top then? We've got cos theta over sine theta times sine theta. That will give us just cos theta. And then expanding the brackets on the bottom, 1 over sine theta times sine theta, that's just 1 minus sine theta. And then that's going to be minus cos theta over 1 plus sine theta. So now let's add the fractions by creating common denominators. It's going to be cos bracket 1 plus sine theta over 1 minus sine theta times 1 plus sine theta. That would be the left-hand fraction, well that needs to become, and on the right-hand fraction it's going to be cos theta bracket 1 minus sine theta over 1 minus sine theta times 1 plus sine theta. Right then, so let's now add these fractions together and expand the brackets on top and bottom. We're going to get cos theta plus sine theta cos theta minus cos theta, and then for the double negative it's going to be plus sine theta cos theta, and then that's all going to be over 1 minus sine squared theta when we expand the brackets. Okay, so what are we left with then? We're left with 2 sine theta cos theta over 1 minus sine squared theta, but that's the same as cos squared theta. So cancel out a factor of cos from top and bottom, and we end up with 2 tan theta. Lovely. So that's 2 sine over cos, which we all know is the same as tan. So that's equal to now the right hand side. Lovely. Let's now move on to the next one. So this one is cosec theta over cosec theta minus sine theta. So same kind of strategy here. So we're going to have, let's write cosec as 1 over sine. And then on the denominator it's going to be 1 over sine theta minus sine theta. So we can see here on top and bottom we've got fractions where sine's on the bottom of it. So if I times top and bottom by sine theta, that will cancel out those fractions. So 1 over sine theta times sine theta on the top gives me just 1. And on the bottom, 1 over sine theta times sine theta is 1. And then it's going to be sine theta times sine theta is sine squared theta. Now we all know that 1 minus sine squared theta is cos squared theta, which is equal to sec squared theta, which is equal to the right hand side. Lovely. Good. Now hopefully what you've noticed is that when we get to things like this, it's really helpful to times top and bottom by the denominators of the fraction on the top and the fraction on the bottom, so that we've just got a two-tiered fraction. It's really important you get things to a two-tiered fraction as soon as possible. Right then, let's have a go at this one then. It's 1 over cosec theta minus 1 plus 1 over cosec theta plus 1. So on the left hand side, what I'm going to do is I'm going to rewrite this as 1 over sine theta minus 1, and then plus 1 over sine theta plus 1. Next thing I'll do is I'll times top and bottom of both the fractions by sine, so it's going to give me sine theta over 1 minus sine theta. And the second part, it's going to be 1 over 1 plus sine theta. So not 1 over, it's going to be sine theta, because you have to times top and bottom by sine theta here. So it's times top and bottom by sine, times top and bottom by sine on both of them. So that's what we've done from first step to second step. Next step will be to put the fractions together. So sine theta multiplied by 1 minus sine theta plus, and that will be over, 1 minus sine theta, 1 plus sine theta. That's creating common denominators on top and bottom. No, actually no, it didn't for this one. It's a plus on the top, because I've had to create an extra 1 plus sine theta on top and bottom for this one. The next one is going to be sine theta 1 minus sine theta, and then 1 minus sine theta, 1 plus sine theta, whichever way around you want to do it. Right then, now we can add these two fractions together, but I'll expand the brackets as I go. So sine theta plus sine theta is 2 sine theta. And then it would be sine squared theta minus sine squared theta, so those two will just cancel out. And on the denominator it would be 1 minus sine squared theta. Now we all know that this would turn into cos squared theta, so it's 2 sine theta over cos squared theta. And now let's try and turn it into what we want it to be, so we'll turn that into 2 times by 1 over cos theta times sine over cos theta. How did I know to split it up like this? Well, it's because that's effectively just what this is. I'm always trying to get towards this as much as possible. So therefore it's equal to 2 sec theta tan theta. And there we are, that's the final answer. And how we do this question, equals right hand side. Okay then, let's move on to the next question. Right then, here we have sec theta minus tan theta times by sec theta plus tan theta over 1 plus tan squared. Now there's an identity to do with sec, tan and 1. Let's just figure out what it is. It's sine squared plus cos squared equals 1. That's the base identity. But then if we divide all this by cos squared, then we get tan squared theta plus 1 equals sec squared theta. So I know on the denominator here I could simplify that to sec squared theta. But what I'll do first is I'll expand the brackets. So I'm going to get sec squared theta. then it'll be minus sec tan, and then plus sec tan, so those two will just cancel, and then it'll be minus tan squared theta. And then on the bottom here, it's going to be sec squared theta, because that's the identity. Now I can use the identity as well on the top. If I just take away tan squared onto the other side of this identity on the right, that just leaves me with 1. So that's going to simplify to 1 over sec squared theta. So this is effectively 1 over cos squared theta. And if you've got 1 over something, that's just equal to cos squared theta, which is equal to the right hand side. Lovely, so there we are. That's how we do this one. 2 more to go then. Sine theta over 1 plus cos theta plus 1 plus cos theta over sine theta equals 2 cosec theta. So let's create common denominators and add these fractions together. So it's going to be sine theta times by sine theta over 1 plus cos theta times by sine theta. And the second one is going to be 1 plus cos theta times 1 plus cos theta over sine theta 1 plus cos theta. Okay, let's now put these two together then. So it's going to be sine squared theta plus 1 plus 2 cos theta, expanding the brackets on the right, plus cos squared theta, all over 1 plus cos theta sine theta. I don't think it's worth our time factorising the bottom, so expanding the bottom. So let's see what we can do on the top then. So it would be 2 plus 2 cos theta over, yeah, you can see what's happening here now, 1 plus cos theta times sine theta. So factor out the 2 on the top and cancel out 1 plus cos theta, and you end up with 2 over sine theta, which is equal to 2 cosec theta, which is equal to the right hand side. Lovely. So there we are. Okay, on to the final one now. 1 plus cos theta over 1 minus cos theta is identical to cosec theta plus cot theta squared. What I think I might do here is I might work on the left hand side and the right hand side a little bit. I think probably the right hand side might be a good place to start. If I expand the brackets, I get cosec squared theta plus 2 cosec cot theta plus cot squared theta. Right, so what can I do now then? I can... there is an identity that links cosec squared and cot squared. Let's have a think about what that might be. It's sine squared plus cos squared equals 1. If I divide by sine squared, I get 1 plus cot squared theta equals cosec squared theta. So therefore, what do I want to change? I'll change the cosec into cot maybe. So it would be 1 plus 2 cot squared theta plus 2 cosec theta cot theta. Okay, this isn't looking that helpful so far. Maybe what I should do is put this in terms of a fraction. So it would be 1 plus 2 cos squared theta over sine squared theta plus 2 over sine squared theta cos theta on the top. Okay, this might be a little bit helpful. So let's make it sine squared theta for the 1. We'll make it sine squared over sine squared plus 2 cos squared theta plus 2 cos theta all over sine squared. Okay, let's get started on working on the left then. So 1 plus cos theta over 1 minus cos theta. I think I'll do a little trick of, you know, the rationalising the denominator trick where you take the bottom and times by the conjugate of it. It's 1 plus cos theta on the top, 1 plus cos theta on the bottom. So what will we get there? That will be 1 plus 2 cos theta plus cos squared theta all over 1 minus cos squared theta. So 1 minus cos squared theta is sine squared theta, so I've got the same on the denominator now, so I must have something that matches up on the numerator. What I'll do is I'll turn this 1 into sine squared plus cos squared, so sine squared theta plus cos squared theta, and then that would be plus 2 cos theta plus cos squared theta. So let's now group the cos squareds together, so it would be sine squared theta plus 2 cos theta plus 2 cos squared theta all over sine squared theta. And you can see now that what we've got on the left hand side is rearranged to what we've got on the right hand side, so therefore left hand side equals right hand side. And there we are. That's the little proof for this final question here. That was a really tough one there. We had to work on both sides quite a lot, but we did end up with left hand side equals right hand side. So there we are. That's the Trigonometric Identities video for the cosec, sec and cot edition. There's another one coming up to do with double angle formulae, so if you're at the end of your A-level career and you're now revising for your exams, move on to the double angle formula one, because that will be really helpful as well. And don't be afraid to go back through this video in a week or two's time, see if you still understand how to rearrange the identities and prove the identities. Doing it again and again is going to be worthwhile, cementing those techniques into your brains, because these are really tough questions, these. But thank you very much for watching, and hopefully you found it useful.